There has been a long tendency to see the most important innovations of modernism as arising directly from progressive social causes. War, in this view, was considered a limiting, if not wholly destructive force that stymied civilian architecture in favor of retrogressive military structures. However, a closer look at history offers a far more complicated image for architects and architecture's role in war, even perhaps an inescapable truth. The full potential of 20th century architecture, engineering, and design was not realized in the social welfare and urban improvement schemes beloved by the early proponents of the modern movement, but rather through technologies perfected during the two world wars. Technologies used to slaughter vast armies, destroy entire cities, decimate non-combatant populations, and industrialize genocide. While many architects were called to serve as combatants, others pursued professional work in the service of intensified industrial production. The war drew on every aspect of expertise and led to significant design innovations and advances in technology and production. As a result, architects were almost always used strategically, and they did become strategically indispensable as engineers and scientists in contributing to the war effort. The history of architecture during World War II is covered in a relatively limited fashion in most history textbooks. We all know about Albert Speer, the man who slavishly carried out Hitler's megalomaniacal architectural fantasies. Some know about Mies van der Rohe's exile in Chicago. Much of the rest, however, has seemed to have faded from view. In this lecture, we're going to look at what happened with architecture and architects, at least a sampling of them, during the war, and then in part 2 in the years that followed. We're familiar with images of cities at war, including photographs showing the ruins of cities like Cologne above, following the Allied air raids. The images speak of the scale of architectural devastation and the implication of architects both in the destruction of cities and, of course, in their subsequent reconstruction. The reality is that many of the architects we've been studying were called into service during the war. Their many different contributions reflect the variety and intensity of the wartime experience. The list of such architects includes designers like Oliver Aalto, Henry Dreyfus, Norman Valgettis, Charles and Ray Eames, Buckminster Fuller, Erno Goldfinger, Myron Goldsmith, Walter Gropius, Albert Kahn, Le Corbusier, Erich Mendelsohn, Ernst Neufert, Richard Neutra, Albert Speer, and Bruno Zevi. High among the major misconceptions is that World War II brought the building art to a veritable halt. Although non-essential commercial and residential construction were indeed banned for the duration of the war in the United States, architecture and engineering proceeded apace in the military sphere. Urgent contingencies spurred the rapid development of new synthetic material, especially plastics of all sorts, and imaginative technical solutions, including lightweight and portable structures, as well as new forms of prefabrication that would have taken far longer to emerge under less pressured peacetime conditions. The Second World War extended its realm far beyond the combat zone, and each fighting nation mobilized a civilian workforce of unprecedented proportions to support its total industrialization. What you're seeing here is a graphic, a guideline for an air raid in Tokyo, dated 1943. So graphic design is a potent tool of propaganda, but also education. Wartime rationing included finding alternative or recycled materials to be used in place of strategic material reserves for war efforts. Home energy consumption was reduced with introduction of new insulating materials, and homegrown food was encouraged to offset shortages. This Hubert Rogers poster shows 3 determined Canadian soldiers, a factory worker, and a farm worker committed to actions in their own areas. In addition to propaganda designed to boost morale, the idea of winning the war on the, quote, home front, unquote, was echoed in cultural institutions that tried to educate and guide citizens. In 1942, the Museum of Modern Art in New York City presented Useful Objects in Wartime, an exhibition of simple domestic objects produced with non-strategic materials. Civil engineers and architects played a leading role in construction of thousands of factories and accompanying worker housing required to produce aircraft, vehicles, and munitions. To reduce the risk of aerial attacks, almost all countries created new industrial landscapes by removing production sites from the proximity of national borders and large cities. So we start to see the emergence of industrial parks and zoning of this kind of manufacturing quite far from city centers. Many complexes took on the scale of real cities, often employing tens of thousands of workers. Among these are highlights such as Albert Kahn Associates' Chrysler Tank Arsenal and Ford Motor Bomber Plant in Michigan, both steel frame structures with glazing on all sides. Scale is evidenced in Albert Kahn's work, such as the Ford Motor Bomber Factory at Willow Run, Michigan, and of course also the Chrysler Tank Arsenal I've just mentioned. This photograph of the seemingly infinite interior of the drafting room of the former point not only to scale in the sense of structural span, size of the enclosed space, or the workforce contained within it, but also in terms of environmental control, of technological reach. For the interior climate, the maintenance of consistent quality in air and lighting answered the demand for controlled 24-hour working conditions to produce the war. The emergence of scale in all senses, but particularly in the isolated industrial landscape, would continue into post-war planning. The image here is of the Chrysler Arsenal tank plant in Detroit, and you can see very clearly the scale. This tank arsenal was the first ever built for mass production of American tanks. When World War II erupted in Europe and Germany began using tanks in its blitzkrieg offensives, the United States did not have a tank production program at all. However, they responded quickly. By the mid-1940s, the U.S. realized it needed an armored force separate from its infantry, and in response to this need, the Detroit Tank Arsenal plant sprang up seemingly overnight in the winter of 1940-41 on 113 acres of farmland located north of downtown Detroit in what is now the city of Warren. The mammoth structure measured 5 city blocks deep and 2 blocks wide. Owned by the government and run by Chrysler, the plant received its first contract to build 1,000 M3 tanks in 1940. The government accepted the first M3s on April 24, 1941, while the plant was still under construction. The delivery was marked by a festive occasion, broadcast over a nationwide radio hookup. VIPs and plant workers cheered as the tank fired its guns, smashed telephone poles, and destroyed a mock-up house. The plant also built M4 Sherman tanks. The plant set an all-time monthly production record by delivering 896 M4s in December 1942. In all, during World War II, the Detroit Arsenal tank plant built a quarter of the 89,568 tanks produced in the U.S. overall. Its production, this single tank plant, closely matched tank production in both Great Britain and Germany. During the Korean War later, the plant was modified to build new battle tanks, the M47 Patton. In all, Chrysler built 3,443 M47 Patton tanks between 1952 and 1954, and so on. In the 60s, the plant produced 500 of the M60A2 tanks and continued to be a viable production site through the 1970s. It was not until the plant was closed in 1946 and the government transferred the property to the city of Warren, where it is located for reuse and development. Now, we've heard about Mies van der Rohe's work previously, but maybe not this one. His first American building is the Minerals and Metals Research Center, erected in 1943 as part of his master plan for the Illinois Institute of Technology. So he too, and you can see here in these images the idea of the scale, the very modern detailing of these buildings, the use of the grid, glass, and steel. Certainly a wonderful example of Mies van der Rohe's skeletal, skin and bones construction strategy. Now, less spectacular, but more relevant in many ways to daily life, are some of the low-cost worker housing projects that were built to serve the booming military-industrial complex. Richard Neutra's 1940s Channel Heights Defense Housing in San Pedro, California is a wonderful example. This is a complex of simple, prefabricated houses arranged around a gently sloping park to take advantage of the waterfront views. It is a wonderful exemplar of how to build housing that is cheap, affordable, and humane. It was this particular project was built for workers at the U.S. Navy shipyards. And you can see here in this image that it's an articulated sort of modern architectural language. It comprised 600 units with custom designed wood furniture and was accompanied by public facilities ranging from daycare centers to supermarkets. And here you can see some other images of this complex and also of the site plan, which this type of new construction set a new kind of standard for what urban planning, and particularly residential planning, could look like. Families living in the low-rent structures had access to a health center, gardens, daycare, and even a wood shop for the workers to build their own furniture. And here's a model of the site, and you can see how it's gently sloping. It's meant to provide views also for the people dwelling there. The rooms were Spartan but comfortable, outfitted with built-in furniture and Neutra's famous boomerang chair. I'm showing you this image here, part to give you a sense of the interior of the homes, but also notice this beautiful and very informative drafting. One of only two known examples to survive, this lamp is the epitome of what would later be known as, quote, form follows function, unquote. 4 simple planks of wood, a pane of glass, a light bulb, and wire come together in an elegantly simple design that captures Richard Neutra's essence. And this is one of the fixtures that would have been located in these homes. Neutra's programmatic architecture is reflected in the cantilevered and asymmetrical elements of this lamp. Another example of housing is seen in suburban Pennsylvania, and this is Walter Gropius and Marcel Breuer's Aluminum City Housing, a complex of simple, modern, wood-clad houses that are joined by covered galleries. In fact, some believe that this would be a pretty good model for low-cost housing today. And here you can see the long facade, very standardized, the use of modern windows, repeated elements. These were all cost-saving measures, of course, during the war. Some other black and white images. Now, we looked at this in terms of functionalism. This is Buckminster Fuller's Dymaxion House. And in this context of this lecture, I want you to consider what this would have meant during wartime. So with armies operating thousands of miles from home bases on 4 continents, World War II required intensive movement of equipment and manpower. Architects were concerned with developing lightweight, modular structures that were easily transported, assembled, and disassembled. It is for this reason that designers such as Buckminster Fuller brought their tremendous talents to bear on this idea of a quickly installed housing prototype. And so Fuller designed the Dymaxion deployment unit using steel elements of grain silos to house the American troops in the Persian Gulf in 1942 through 1943. And here you can see, again, this is the modular bathroom system, which Fuller created with no seams that could be not easily cleaned. Again, a focus on sanitation and efficiency. And he also wanted this to be something that could be kind of stamped out and replicated very quickly to help reduce the cost of bathrooms, which tend to be quite a high ticket item within the home. And here you can see an example of one of these Dymaxion houses that was in fact constructed. In addition to the Dymaxion house example, there's another one that is probably even more important in that it was used extensively, whereas the Dymaxion house was perhaps prematurely abandoned. This is the Quonset house, and the Quonset hut was really the simplest and easiest structure to produce. In fact, 170,000 examples of the lightweight barrel-vaulted shelter were produced to house soldiers and refugees, and their everyday use was captured in moving sketches by the young architect Myron Goldsmith. You can see the image on the left. The Quonset hut semicircular form was copied from the British Nissen hut. By the end of the war, it differed considerably in construction from its prototype. The original Quonset hut was framed with arch rib members of steel, T-sections 2 inches by 2 inches by 1/4 inch. The hut was 16 feet by 36 feet in plan. The members were formed to a radius of 8 feet and covered with corrugated steel sheets borne by wood purlins. The principal improvement over the Nissen type were an interior pressed wood lining, insulation, and a tongue-and-groove wood floor. Innumerable detail problems were encountered in the development of the original T-rib huts, principally because of the necessity for 48 different needs, such as galleys, showers, latrines, dental offices, isolation wards, and bakery. Each type required individual drawings and layouts for the interior setup, and in many cases was necessary to develop special interior equipment, such as ovens and beds, to fit the Quonset hut form. All huts were designed and detailed using this original T-rib design. As finally developed, the Quonset hut required less shipping space than did tents with wood floors and frames, when equal numbers of men were to be accommodated. Originally, all Quonset huts had unpainted galvanized exteriors. To reduce the chance of enemy observation from the air, an olive drab camouflage paint was applied at the factory. After 1942, the factory service was extended to include packaging for overseas shipment. And here you can see examples of the hut and how it was deployed. And here you can see this is actually a post-war photograph, and this is on the back of the photograph. It says 1911 field February 1947 with Quonsets and temporary buildings going up North Carolina State. So we can interpret from this that this was in 1947 and they had temporary housing in the form of Quonset huts going up at North Carolina State. And this was built to house the influx of students that came to North Carolina State after World War II due to the GI Bill. So these inventive and imaginative advances in temporary structures are really interesting, but they are overshadowed somewhat by the grinding machinery of war that increasingly demanded a very regimented and maybe even dehumanized society. And architects, of course, were tasked with housing many of these functions as well. One of the many chilling examples of this is in Ernst Neufert's 1943 proposal for the Hausbau machine, or house building machine, an enormous industrial shed that would have moved along rails, stopping every few hundred feet so that workers could pour the next segment in an endless row of identical concrete housing units. The project, never built, is a particularly sinister expression of a world where life is stripped of individual identity and where human beings are treated as interchangeable parts in a gigantic machine. The Hausbau machine was featured in 1943 by Ernst Neufert, and I should note that he was Albert Speer's main deputy at the German Ministry of Armament. And Neufert hoped in this project to fulfill the dream of the ultimate mobile factory. It was planned as a giant machine designed to construct automatically, through the press of a button in theory, full houses. However, this never left the drawing board and the machine was left unbuilt. And here you get a sense of how this would have operated. The machine moving along these rails, leaving behind it a sort of repetitive housing structure. So we've seen some contrast in scale here. We've seen a lamp designed for housing in California. We've seen the Hausbau machine, a machine for building homes, apartments. We also can see gigantic systems of fortifications, which we'll look at briefly now, some of which still stand today. Built following Hitler's orders, the Atlantic Wall consisted of 15,000 concrete fortifications extending over 2,600 kilometers from northern Norway to Basque Country in Spain. And you can see in this image here, we call it the Iron Coast, and Iron Coast because these are the fortified locations all along that coastline. This is a nice image on the right because you can see the differentiation between Army and Navy divisions, the artillery batteries, etc. This is a huge, huge construction project. Here's another image. You could also see German soldiers inspecting some of these defenses in France. And in addition to the Germans, we also have the construction of large air raid structures in Great Britain and other Allied countries. This example I'm showing you here is the Tecton Group. This is their 1939 proposal for an air raid shelter in Finsbury in London. It's a very impressive work of architecture. It's a wide concrete cylinder buried in the earth with a ramp spiraling down its interior wall. This would have been big enough to hold 7,600 people. So you can see here that architects were working both defensively but also offensively, as we saw with the German fortifications. Now, in this plan, I hope you'll remember the name Tecton Group and think back to the London Zoo penguin ramp. Well, it's the same company, the same firm that designed them. And you'll notice here their continued affinity for spiral ramps. Another interesting use of architecture and design can be seen in this project. This is in the United States. Architects Eric Mendelsohn and Konrad Waxman worked with designer Hans Knoll on creating a German village in Utah, with the sole purpose of studying the effectiveness of different forms of bombing. The prefabricated wood structure was also accompanied by a Japanese village, designed by Antonin Raymond. And these were meant to be authentically decorated homes with relevant domestic equipment and bedding. Why? Why did they do this? Well, once the United States entered the war, it became apparent that in the event that gas and biological weapons were used, there had to be a place far enough away from populated areas to test these and other weapons. Roosevelt set aside 120,000 acres in the Utah desert as land for weapons testing near the Dugway Mountains. So you can see here, this is the Dugway Proving Grounds in Utah. And the Dugway Proving Grounds opened in 1942, and this is where these German-Japanese villages were constructed. A local Utah contractor was hired to build both villages, which were side by side. With a mandate of less than 2 months to complete the buildings, the contractor pleaded for help with getting manpower and was allowed to use inmates from the Utah prison as construction workers. The German village was a block of 6 row houses built back to back to mimic the German rent barracks, which were typically low-rent living quarters in large cities such as Berlin. Normally 5 to 6 stories high, the ones built at Dugway were only 2 stories plus the attic area. The attics were the only portion of the brick buildings that were mainly wood, and these were the target of the incendiaries. One side was built with the Western German style of slate over board, while the other side's roofs were covered with tile over batten, as was common in Berlin. Douglas fir and southern pine were used to simulate typical German Kiefer wood for the flooring, roof joists, and beams. Because the tests needed to be as accurate as possible, soldiers were assigned to constantly spray the exposed inner framework with water to keep the wood's moisture content from falling in the desert's low humidity. The German village was designed with assistance from the famous architect Eric Mendelsohn and Konrad Waxman and others from Walter Gropius Group at Harvard. The structure was designed as a duplex unit divided into 6 apartments, all having a second floor and an attic, again because that was the most flammable part of the building. The structure was mostly masonry, and the floors of this type of building were not only more massive, they actually contained 3.5-inch cinder infill that made it very difficult for a fire to burn more than the upper floor and attic. Because of this, the first floor was left unfinished, and only the top floor was dressed. Once the furnishings were completed and had arrived on the site, staff members supervised the installation based on interior layout created by an art department. Again, artists and architects deeply involved in this effort. The small rooms were filled to match the congested look of the average German tenement apartment, with beds, sofas, cabinets, cribs, tables, and chairs, and the furnishings were completed with the addition of cushions, beds, and crib linens. They also included small details such as window dressings. The Japanese village was designed by the Czech architect Antonin Raymond, who had worked with Frank Lloyd Wright on the Imperial Hotel in Tokyo. He had set up his architectural practice there and would become known as the father of modernist Japanese architecture. Intimately familiar with the typical wooden structure of the Japanese house, he provided construction drawings and suggestions for the building materials. The list of furnishings needed to dress the buildings for the test was staggering, considering these had to be built in such a short time. Over 760 pieces of furniture were called for, as well as over 700 mattresses, pillows, and drapes, and over 900 tatami mats were needed for the Japanese structures. Every tatami mat in San Francisco and Hawaii was rounded up and sent to Utah. When these proved insufficient, others were constructed using Mexican ixtal fiber as a substitute. The black and white photographs taken of the rooms on May 16, 1943, the night before the test began, look so much like movie sets. The villages were constructed in just 44 days, and bomb tests began the very next day and were repeated for nearly 4 months. Each time, the structures, designs, and built by architects and artists were quickly repaired and refurnished.